Mr. Ringer is a senior product manager at Skyward, a company that he co-founded and that was recently acquired by Verizon. In his role as senior product manager, he builds solutions to save time by allowing people to scale faster by connecting everyone, the projects, and equipment involved in a drone program into one efficient workflow. Prior to Skyward, Mr. Ringer was a system engineer at contractors for both NASA and Sikorsky. Mr. Ringer will be talking about robots taking flight. Please give a warm welcome to Mr. Ringer.
Thank you all very much. All right, so I know that you all love working with the robots. That's what First Robotics is all about. But traditionally, most of the robotics are bound to the surface of the Earth. My company, we get to work with robots that actually take flight. Adding that third dimension really expands the possibilities for what we can do with these robots. Steve, the bald futurist, talked earlier about the ways that sensors are being deployed kind of throughout the world. I think his statistic was 100 trillion sensors out there. Drones are basically a way to deliver that sensor closer to whatever it is that needs to be detected, whether that's temperature, whether that's wind, taking pictures of a crack in a cell phone tower to assess the damage. There are a lot of different possibilities with these robots. And you can imagine a future where the robots are being deployed programmatically. That means the human itself, you're not flying it anymore. The drone is being deployed in the same way that you would start a program or an app on your iPhone. I'm a mechanical engineer, so I like to think about the physical. And so if you imagine the internet, packets of information flowing through the tubes of the internet, they're going along and getting routed exactly where they need to go. It kind of looks like magic if you don't know all the details of it. The same, I think, is going to happen in the future with robots, with aerial robots and ground robots. But because we have that third dimension to work in, it gives us a lot more flexibility with the aerial robots. So I always like to think about it as like the Jetsons or Blade Runner or Back to the Future, but I get that that's kind of dated reference for a lot of you all. Are there any video games or movies today that kind of depict the future of flying cars? Just yell out something that comes to mind if you have one. What is that? Okay, I'm not familiar with that one, but I'm going to assume that others know what that is. Okay. Regardless, there's this future that we depict in science fiction that I think has a real possibility of coming true in the next 5 to 10 years. So I'm Eric Ringer. I have a bachelor's in mechanical engineering. I have an MBA. I've worked for NASA and Sikorsky contractors, as was said in my introduction. And then I founded a company called Skyward just a few years ago to really dig into what drones can do in our society. And drones, it might sound fun to fly them. Actually, I brought one to just show you guys. I'm not actually going to fly it, but just to show you guys the size. But they sound fun, but for businesses, for them to actually make use of them, they can be a little bit scary. Mostly because a lot of these businesses that are now using drones, as small as this, they're not used to having an aviation asset. Meaning, they're not used to having to follow the rules involved in aviation. So I'll unpack this in just a minute to show you guys generally the size of it. But a little bit more about my history and how I even got to aviation in the first place. And maybe you'll, as you go along through school, this might help guide you as you've seen maybe the way that I've come through and gotten to where I am today. It might help you with your own journey as well. I love the aerial perspective. So I love hiking up to the tops of mountains. I love living in Oregon because of that. And I love seeing how big, grand features become small and miniaturized. And so I love doing that through hiking. I love doing that through flying. So this is flying with a business partner of mine, flying into the Medford airport just after the sun went down. I love doing it with drones. And so I love taking this little guy out and flying. This is floating down the Deschutes River. It's just new perspective. And so that's what's driven me in my career so far. So I got my bachelor's in mechanical engineering in 2010 because I loved knowing how things work. I loved figuring that stuff out. In 2008, I did an internship at the Johnson Space Center, NASA, and I got to work on the lunar rover suit port. So if you imagine an astronaut out walking on Mars or the moon, and they get up to the lunar rover or the Mars rover, and they just basically put their backs on to the capsule, and it gets a seal, and then this door opens, and they can just kind of step out the back and go into the vehicle. I also have gotten to work on these giant aircraft. The CH-53K is a big heavy lift helicopter for Sikorsky, and it's just now gone through flight testing and getting out to getting delivered to the Marines. So this was my first job out of college. I got to work on aircraft, Blackhawks, the CH-53K. But what I found in both of these jobs is that as an engineer, I didn't quite fit in with the rest of my engineering friends. For instance, on the Blackhawk, I was in charge of these little rivets. I had to make sure that these rivets were not going to corrode. I had to make sure that they aren't going to be the point of failure in the aircraft in whatever environment they're in, whether that's at sea, where the salt contributes to the corrosion, or it's in the desert, where the sand can erode the material. And that's a very important part to make sure that it doesn't fail. And as you can imagine on an aircraft, there are tons of parts, so you gotta make sure it don't fail, because people's lives are depending on it. But for me, I didn't find much satisfaction in taking responsibility over that small part. I was much more interested in the whole aircraft. Now, I had a lot of friends and colleagues in engineering that they took a lot of pride in that, and that was what they were going to drive their life's work to, because they felt the concrete contribution that they made to that aircraft. But for some reason, for me, it didn't quite fit. So I went back to school to get my MBA. I wanted to take that whole aircraft and put it into the market. I wanted to take all the pieces and parts and put it together and put it in the market. It's a big team effort. So I mentioned earlier, I like figuring out how things work. So I pursued that in mechanical engineering, how do you build a machine. And then in the MBA, I figured out, I also like figuring out how people work together. And so then, instead of building a machine, building a company. So when I got to the MBA program at the University of Oregon, I met my co-founder, Jonathan Evans, a guy with a lot of big ideas, very excited about a lot of things. And he had flown Blackhawks in the Army, whereas I had just been working on those rivets on them. And we made an instant connection. And he said, Eric, I think you're a smart guy. I think drones are going to be a thing. We should do something about that. Do you want to start a business where we just kind of figure out over these next couple of years in school something that we could do? So I was like, sure, I got a couple of years, why not? So I said yes. We formed the company, Skyward, and we bought this drone that you put together. 5 years ago, this was state of the art for drones. We put it together, we went out to the field, went to take off, got 3 inches in the air and flipped over. So it turns out I'm not that great at building robots. But that wasn't the point. The point was to step out and get our feet wet, to figure things out. We were in this exploratory phase of the company. What were we going to do in drones? If drones were going to be a big opportunity as an industry, what mark were we going to leave? So we were exploring it. We could look at hardware. We tried it out with this drone. We could look at software. Could we provide software services some way? We could look at actually flying them. Can we provide flight services to somebody? So we explored all of this. We looked at the history of technology, and the very first thing to commoditize, meaning the money that you make off of it gets squished so it gets low, so you're not making tons of money, is hardware. Looking at the cell phone industry, the iPhone came out, that was big, that was great, and then a lot of competitors glommed on really quickly. And also looking at the computer industry. the place that you can make higher margins, meaning you get more money, more profit for the cost that you put in, is in software. And so we recruited a software co-founder and set about interviewing people who are in the drone industry. Now, 5 years ago, this was a challenging time because the commercial drones were illegal. Meaning you couldn't fly drones to make money in the United States 5 years ago. But we could see the tides shifting. And so we interviewed people who had experience operating drones. So this was largely people who did it just for fun, as a hobby, or those who had done it in the military. And we tried to figure out what their biggest pain points were for deploying drones. And we realized that one drone to one person, that's easy enough. But when you start deploying drones in a larger program, meaning you have a business that is in charge of a fleet of drones, and you have to worry about who's going to go where, which aircraft are okay, which ones are maintained well and are ready to go up in the air, how you navigate the rules, where am I allowed to fly, when am I allowed to fly, how am I allowed to fly, that gets complicated. And so we thought that we could help with that through software as a service. So that's what Skyward is. We're fleet and operations management for people who are deploying drones. And then fast forward through about 4 years, and we got acquired by Verizon. So you may wonder, what does Verizon want with a company that does stuff with drones? Well, Verizon provides a connectivity layer. So, with your cell phones, you can call people, you can text people, you can have access to the internet almost anywhere. So Verizon's trying to make use of that connectivity layer, now providing services on top of it. And so now drones can be connected to the internet. The industry is booming, and let me just take a second to undo this. So as far as drones go, this is a pretty small one. I can fit this in my backpack, so I love to go hiking with this one. But the technology inside of it is incredible. And it's empowered by a lot of the same things that Steve was talking about earlier. We've got that huge computing power 30 years ago, now shrunk down into an Apple Watch. Those miniaturized and power efficient computing pieces now fit into a drone. And so you have sensors on here. You got them on the front. You've got them on the bottom. Combination of cameras, ultrasonic, that are determining how far the aircraft is off the ground. They're doing optical, or they're doing, well, basically they're looking for obstacles. So if I were to fly this thing indoors and I got close to the window here, with this shade, it'd be able to recognize that I'm getting close, and it would stop the aircraft to keep it from crashing. All that's happening inside this drone. 5 years ago, when I put that drone together, I would never have dreamed that we would come this far this quickly. And so there are people in the drone, or people in industries that have nothing to do with drones, and traditionally have nothing to do with flight, now figuring out that this thing actually provides a lot of opportunities for them. And it's starting to look like a tool that we can use in our everyday life, similar to pulling out a drill or a hammer. So yeah, it's a little bit more high-tech than that. And it comes with its own set of regulations that you gotta make sure you follow. But they're becoming more and more approachable. So, lots of them, like this is a small drone that I take hiking with me. Some of the ones that are being used for cell phone tower inspections or bridge inspections are larger. They're heavier duty. The law requires you to have one operator to one drone. So that means I have to at all times be at the controls of this aircraft. And I must fly within visual line of sight, which means I can never let that drone out of my sight. But even still with these restrictions, we're still seeing a lot of efficiencies in the way that you can get things done with drones. For example, on oil rigs, they have these things called flare stacks that are kind of burning off excess gas. Right now, in order to do a flare stack inspection, you have to shut down production of the oil rig, which costs these oil rigs hundreds of thousands of dollars. And if they're down for long enough, into the millions of dollars. And so they shut down that production so that they don't have to have the flare going, so that you can send a guy up there to do the inspection. And these inspections are mandated by law. With a drone, you don't have to shut down production. You just send a drone up in the air. Yeah, you have somebody flying it. But you don't have to shut down production. So just by virtue of not having to shut down production, you're saving hundreds of thousands of dollars just by using this drone. Bridge inspections. Today, they're using a pretty traditional method that's been done for quite a long time. But bridges have to be regularly inspected. They do it by several workers in a bucket truck, kind of going under the bridge there. They use their eyes to look for flaws. But drones are now being used to provide a more efficient and reliable option to get that job done. You still have one worker to one drone, but you're using sensors now to gather the data. And now you're storing that data to reference later. So whether that sensor is just a camera with a light, or it's infrared, showing cracks in the infrastructure, it's helping people get things done better and faster and cheaper. You're still required 3 things: a human pilot,